Hi, I'm Kevin Dooley from the W.P. Carey School of Business at Arizona State University. And I'd like to talk to you today about our recently published paper in the Journal of Operations Management called Process Network Modularity, Commonality, and Greenhouse Gas Emissions. I want to thank my co-authors, Surya Pathak, Tom Kull, Xiao Wu, John Johnson, and Elliot Rabinovich, as well as acknowledging support for this research from the U.S. National Science Foundation. As a context, this paper is about how do we address greenhouse gas emissions reduction. We know that this is a global imperative and that business supply chains provide both a large amount of the source of greenhouse gas emissions that we have that are human-made, as well as the opportunity for reduction of those emissions. So we know GHG emissions reductions are critical, and in the context of the time frame of which we collected data and whatnot, there wasn't a lot of renewable energy that was widely adopted. And so GHG emissions, as we're talking about here, are largely driven by the amount of energy that processes within the supply chain that create a product or service gobble up as those processes and equipment operate. And yet, if we look at a whole supply chain, it's not just one organization or one group of people who are deciding how to manage technology and operations that affect emissions and energy efficiency, but rather it's hundreds or even thousands of organizations and people across these supply chains that collectively essentially make decisions that lead to higher or lower greenhouse gas emissions across the supply chain. Since we know that one obvious way to improve energy efficiency, reduce energy consumption across the supply chain is for any given unit process within the supply chain to try to make it as energy efficient as possible. That's one obvious way and the most direct way in which to reduce the overall emissions across the whole supply chain. But we wanted in our research, is there something more? In fact, is there something about the way that processes and suppliers are set up in a network, something about the structure of that network that also makes a difference to how collectively, in this case, they achieve lower greenhouse gas emissions? And so our unit of analysis, which is a little bit different than conventionally done in many of our published research, is that instead of using suppliers as a unit of analysis connected in some type of supply network, our work is looking at process networks. And so it's the same idea, but it's at a higher level of resolution. So within any given supplier, they may have multiple processes that essentially create value from a set of inputs. And so they might have a drilling operation and a lathing operation and a transportation operation and a heat treatment operation. And each of those unit processes essentially then collectively across the supply chain make up a process network. And so our theory was to test Simon's architecture of complexity, which led to two basic hypotheses about how this network structure might impact the overall operational efficiency of the overall supply chain. One was that systems tend to evolve towards increased division of labor and specialization. And number two, systems develop efficiencies through modularization. So our hypothesis was that if we observe networks that tended to show more division of labor and specialization and more modularization, this indicated essentially that the system had evolved to a higher level of complexity and thus was going to be more operationally efficient and have lower GHG emissions. And this in fact was confirmed, these hypotheses were both confirmed via a test consisting of over 4,000 process networks. So what are the takeaways from this research? Number one is that process networks deserve attention. A lot of our work, again, concentrates on interorganizational networks, supply networks, And process networks are at that next level of complexity where there's really an emphasis on individual unit processes. And I think in particular to the interest of SCOM scholars, that there are technology management and technology driven research questions that may be better addressed and understood by looking at these process networks as opposed to just organizational networks. Secondly, our research demonstrates that the theories and concepts from complexity science and complex adaptive systems can be tested empirically. And it takes creativity and honestly a lot of work to get the data that was relevant to the questions that we were addressing. But hopefully this demonstrates that other theories from complexity science can also be tested with the type of data that we have access to. 3, this study demonstrated that supply chain or product improvements can emerge from uncoordinated action of many agents. And so what we were seeing is that as a whole, certain networks had configurations because of how they had evolved that were more efficient, even though there was no one who was coordinating, no single organization coordinating the evolution of those networks. And number 4, the benefits of modularity depend on additive versus multiplicative effects. And so in our case, when we're looking at GHG emissions, they are largely the result of individual emissions at individual unit processes. And there are less multiplicative effects other than innovation effects that we saw in our data. However, we also know that products that are more integral and less modular sometimes can have better overall performance. And so there will always be a tension between modularity and integrity. And in any given case where we're looking at a particular type of performance in a system, we need to look at those trade-offs. Thank you. Hope you enjoy the paper.